Welcome everyone. Have a good afternoon for all of you. So let me just introduce myself. I'm Matt Lipcsei. I'm a product manager here at Commsignia, responsible for the smart city products. So and I'm going to just jump in instead of Laszlo. Hopefully, it will be an interesting presentation for you. While I'm showcasing, the bleeding edge of the connected mobility advancements that we have today. Before jumping in the middle of the topics, please let me introduce Commsignia in a couple of words. Commsignia has been one of the first companies dedicatedly started to work on V2X since 2012. Our founders were also researchers, and we're working on V2X related topics since university. So we are building on their very nice experiences. Actually, you might have heard about Commsignia regarding V2X deployments and V2X communication. In the States, actually, we have created maybe one of the largest deployments in Las Vegas. I think it should be around one of the largest deployments in North America. We also drive standardizations in multiple bodies, so we could be familiar from those channels as well. And actually, we already have our own products and production-grade hardware and software products, both for smart cities and automotive as well. Commsignia last year has received a nice investment of $11 million to fuel the growth of the company. So basically, we have 3 pillars that we build on with regards to the activities of the company. As I've mentioned, it's the automotive side, the smart city side, and of course the research side, when we try to get the most out of this technology as much as possible. So going back to today's topic and question, we were preparing with this presentation because the number of smart city deployments are really growing today. So that's a fact. Everybody can just recognize that from the news, from different procurements. But we recognize that these deployments and these smart city projects are mostly focusing on vehicle targeted use cases. So this is a good question to ask why it's happening. So we should care about the vulnerable road users as well. And it's kind of a challenge. So if we start thinking about why it's a challenge, because they are not connected, so we cannot really get to those people or get to those cyclists easily yet, because hopefully in the future we'll have multiple ways to really have a direct connection to them. So basically this connectivity will be resolved by time. So, and what else is making it hard? So it's also detection issues that we need to care about and think about when it comes to difficulties. Latency, for example. So detecting someone who is not connected and not really directly enabled in this connected space is going to have some latency. And no matter what technology we are just talking about, we need to care about that. And of course, the detection infrastructure could also be very expensive when it comes to detecting not easily detectable objects and people on the road. So this could be also a challenge to resolve. Of course, it's very hard to detect something which is not really broadcasting any information about itself. And these are environmental issues that we need to come over by time. So and with regards to that, we have multiple aspects that we need to just take into consideration when we are talking about relevancy, the speed of those people and moving objects around the road, we need to start thinking about if we are trying to, recognizing one individual person or clustering them somehow, and find some ways like that. And of course, all these steps need to be done very quickly, as much real time as possible. So these are all challenges that we need to address when trying to create a solution for vulnerable road users. And let's see what we have today. So what we can build from today's infrastructure. As you can see, and as you can know, we have multiple sensors already existing around our roads and around the smart cities. It is very interesting to start thinking about how we could just leverage all those sensor technologies that we already have today. No matter if it's a loop detector, if it's an IP camera, or some intelligent camera that can even recognize different objects on the road, or radar technology. The main takeaway here is that these data systems and data generating systems are usually, connected to some computation power on the edge. This is usually an RSU, and an RSU is able to evaluate that data, which is generated by all these different sensors. So an RSU is able to, real-time fusion all this information and conclude some conclusions of all this data. For example, generating alerts from this data is a very nice way of working with all these sensor inputs, and it could be utilized to somehow open up the possibilities of what we could do with the existing systems. And let's check how these sensors could be utilized today. So we are at the very first and very easiest way to address the issues. We already have a so-called pedestrian safety message described by the standards. It's declared in the US, so it's not available in the EU, but it's available in the US. But the problem is here that there are no active devices at the pedestrians yet that we could utilize, and we are not able to get direct information from the pedestrians because the currently available devices are not providing this information. Pedestrian safety message is kind of a here I am message, including the location, the speed of the person who is just broadcasting that message. And the good point with that is we do not really need an infrastructure to really handle all this data, because the pedestrian safety message is broadcasted by the pedestrian and can be received by the car. So basically, we do not need any third party to interrupt in the communication. But if going forward and solving this problem that we do not have any equipment that could provide pedestrian safety message, we should just focus on available solutions which we already have access today. And this is, for example, cameras which could detect pedestrians. And these cameras could just send some signals to the RSUs, warning the RSU that it was recognizing a pedestrian. This signal could be very diverse. So it could be like the image stream or the video stream itself, and let the RSU just process that and recognize the pedestrians. Or, as I've mentioned, there are multiple smart cameras available, which could already do the detection part for us and just provide the information that someone is on the crossroad. So we could utilize this information and use the RSU to send out PSM message. Actually, this PSM message is being sent out on behalf of the pedestrian. which is, making it a bit more complex from, for example, V2X communication related perspective. V2X communication could be secured, and when you are just sending messages on behalf of other parties, it can be a technical difficulty that you need to overcome. So basically, the solution might not be the best, but it is available today. So we could, utilize these sensors and save lives with those. So let's move on to another possible solution that we could utilize. This is the collective perception message. Finally, this message is available only in the EU. Sorry. So this is described by the ETSI standards. It is being developed in the US, but not really available today. So what this collective perception message is, it's kind of a sensor information sharing technology where you could just send the message like there's a pedestrian on the road, including its location, speed, and other parameters. And this CPM could be sent by the RSU itself. So the whole message was designed to be sent out by third parties and communicate different sensory information. So it's working for basically any vulnerable road user type, pedestrians, cyclists, animals, no matter what. And it can be also used and sensor information could be easily used to just gather this information. When it comes to security, CPM as a well-defined message in the EU standard could be a very good fit from a security perspective as well. The only limitation here that we need to consider that this message is just being standardized in the US, so it's not a global solution to this problem. Yeah. So as I mentioned, the camera is providing the signals to the RSU, just as the previous example showed us, and the RSU now can send the CPM message to the car in a standard way. So basically, that's the message here, that it is fine for an RSU to send out a CPM, which is telling to the cars if someone is on the crosswalk. Another way to really address this is using the SPAT message. Interestingly, the SPAT concretely has a specific field in it that could be used for each directions and each movement in the intersection, and these movements can be marked if there are any detected vulnerable road users or not. Actually, the standard is allowing us to tell that maybe there is someone, so we shouldn't just go for sure or not. So SPAT from this perspective is very flexible, and SPAT is also widely used today by multiple applications on the vehicle. So from this perspective, SPAT is very nice because we need to work with a familiar message that we have already worked with for previous applications. Another perspective here, which is that it's not really disclosing an individual person's data, location, or speed, because this flag that I've mentioned for each intersection movement is kind of a 1 or 0 value to indicate that if there is someone or not. So it's not kind of an individual data, which could be also appealing for specific use cases. And last but not least, SPAT is a secure message, and it's described by the standards, so we can sign that and use that for secure communication. All right. Yeah. So the pattern here is that the detection is happening. That is triggering the roadside unit. The roadside unit is also connected to the traffic light controller, which is telling the phasing and timing information to the roadside unit. And the RSU is fusing these two information together to produce the SPAT and the danger related information to the cars. As a next step, we could just talk about the TIM message. This is a US standard message. TIM is a very flexible message. We can really share a lot of information with TIM messages. We need to really care about that this message is having a resolution time of 1 minute. So basically, the start and end time of a TIM message can be just described in a minute level, which is meaning that it might not be the best solution to describe a moving or a object or movement. So it's not that flexible. Flexible from the content perspective, so it can describe a lot of things. And another key here is that the TIM is pretty much defining a area, and that area has some kind of a message content, and that area has some value-add information assigned to that. So basically, it's not really describing the object itself, but let's say it could just describe an area, and the vehicle could just have the alert that it is approaching pedestrian, let's say, a crosswalk area. So so basically, the TIM message might not be the best solution either, but it is also available today, and we could just create multiple scenarios when pedestrian safety could be just multiplied many times compared to the current situation. All right. So the TIM message has a cousin from Europe that is called in-vehicle information. These two messages are not the same, but their concept and the philosophy behind those are pretty much the same. So the IVI information is also about defining areas and assigning different messages to those areas. This is also not really meant to track down moving objects and moving pedestrians, but it's rather designed to deliver information from the infrastructure about advisory information, regulatory information, and road or traffic scenarios. The IVI, as I mentioned, it's a EU-based message, and it could be really super complex when you just try to put together everything there. So it's really flexible. A lot of things can be just created with the IVI messages, but it might not be the best to track down pedestrians. Okay, and last but not least, we also have a message in the EU, which is called Decentralized Environmental Notification Message. The pro side of this message is that it can be updated, it can be canceled. So we have kind of flexibility around describing different situations. But we also have some limitations or things to overcome when we are using this message. Basically, the denim message is also containing a so-called path history in the message itself, which is describing directions from which the different notifications should pop up. So basically, we can come to a question: which directions in the intersection we should assigned to a specific DNAM message, and at the end we might realize that it's not the best solution that we can choose from, as you've seen the list I've gone through. So what we can work today with is the existing detector systems, the existing radars, camera systems, and basically we can utilize those sensor information to introduce solutions and services which are providing vulnerable road users. We have seen multiple messages which are created and aggregated on the field, on the RSU side usually, and this is happening in real time. But we might need to think about other parties as well, like first responders for emergency situations. This communication usually needs some kind of a cloud access or a cloud communication, which could also be achieved using the specific building blocks of the current architecture of telecommunication systems. But there is only one thing we need to be really cautious about, is that the latency is increasing as far as we just getting further from the data processing points. So as far as we got from the RSUs during this kind of communication, the latency is increasing, and the warning systems need to really take that into consideration when we are designing those. And one other hint here is that putting data into the cloud could really assist us do some historical analysis on previous warnings, hard breaks, and other scenarios. And this could really help the decision makers to make the cities and the environment more safe. So having all these components together can really just enhance the experience we have today. And really important, these are actually options and building blocks we already have today. So let's see some sneak peeks out what we are working with nowadays. Actually, it's very interesting. We are just trying to develop further ways how we could just enhance this vulnerable road user topic. And it's usually asked if the people already have the smartphones with them, why don't we use that? The answer is pretty easy, because actually we do not really have accurate localization with the phones, and we need some other way to get around the location tracking questions. And for this, actually, the ultra-wideband technology is a very promising way that we are aware today. And we also know that this technology is being introduced into multiple phones today, even today. So actually, working and utilizing this technology could really help us overcoming the inaccuracy of the location information. Ultra-wideband communication is allowing us to really triangulate or the pedestrians who are having this technology in their pockets. It's providing a real-time communication mode. It's very nice because it really supports bands that are different from the currently used Bluetooth and Wi-Fi, requiring low energy. So it's perfect for handheld devices. And this calculation method is providing a centimeter resolution with regards to the positioning information. So so this seems to be a very interesting technology of today. And what it's really about is that having this technology included in the smartphones, which are being triangulated by the different anchors installed on the roadside as well, and these anchors are communicating with the RSU, and this is allowing the RSU to get a very precise position of a pedestrian, and this information can be shared over V2X to different cars. So this is really nice solution because it could track the vulnerable road users with a very nice and very accurate positioning. And the vehicles could be informed using the V2X communication. So basically, this could also solve the problem of localizing pedestrians, cyclists on the roadside. Very important that services need to be deployed on the roadside in order that the vulnerable road users could be warned about different safety scenarios, because that's the part when they can get information. So basically, some services need to be introduced to make them aware of the different scenarios. So all in all, we can see that there are multiple actors that could act based on a collision course or on a dangerous situation. It is either the roadside infrastructure, which could assist the vulnerable road users by giving green light or changing it to red, maybe just providing some visual or sound warnings. We could also just utilize the vehicles to make the decisions that are needed to be made, because if they are aware, the pedestrians, they can really make turns, use emergency brakes. So vehicles could also just act based on this information. And last but not least, smartphones could also alert the people about different scenarios. So basically, we have a parallel detection on multiple devices, and basically Commsignia is envisioning that its own applications could run on multiple types of devices to really protect the vulnerable road users. Privacy is also a very important factor that we need to take into consideration. It's getting more and more highlight today with the GDPR in the EU, and I think I can state that privacy is getting more and more important. We are lucky from this perspective because V2X messages and the V2X ecosystem is really safe by design, because the whole standard and the whole V2X communication was designed not to contain unique IDs, not to allow tracking personals one by one. So basically, this is already offered by the V2X communication technology. When it comes to the ecosystem around that, we also have good news, because there are multiple things that we could do for the security. There are so-called security management systems around the V2X communication or PKI systems, and these systems are really ensuring the goals really described by the standards. So basically, that is also a very good point to have these systems around us. We could also think about aggregating data as a privacy filter, because aggregating data could hide the individual person behind that data. So basically, aggregating and working with a cloud of people is also a solution to privacy. So all in all, I think we are in a lucky situation with the V2X because, as I've mentioned, it is designed to be really private and secure from the ground up. So V2X is going to be a good solution to take this into consideration. All right. Let's suppose we have this infrastructure, but I'm pretty sure that you are also thinking about that. We need to, gain some trust with regards to that infrastructure to provide this very, very sensitive and very life-saving information. So as you can tell, quality is a key factor here with regards to smart city roadside units, especially when it comes to vulnerable road users. And the system is really good as its weakest component. So an RSU shouldn't be one of that. We work really hard here at Commsignia to ensure that the devices we provide are taking all the aspects of security and trustworthiness into consideration when we are just creating our products. And actually, it's a very important part when we are talking with OEMs, for example, to take different level of trustworthiness into consideration. So Commsignia is really super interested in working with future RSUs, creating future RSUs and message types, which could take, for example, functional safety into consideration. So actually, we do envision some kind of a special RSU, which has gone through special certification processes and assessed by different auditors, for example, to receive a permission to broadcast valid or life-saving messages. We have been discussing this topic with multiple stakeholders on multiple levels, and we are trying to formulate some kind of requirement list around that to really distinguish the normal or let's say the cheap RSUs, and this is resonating pretty much with the other stakeholders' view of the future. So the infrastructure needs to be really secure, as we've talked about that. Security is the key for the privacy. We need to really produce a fail-safe hardware and software solution, which is guaranteeing the continuous communication and operation. Tamper-proof is also a very important aspect that we need to take into consideration. So when it comes to hacking RSUs, we need to be aware of that, and the RSU should act as soon as it's detecting anyone really trying to just get into the device or abuse the communication. Environmental protection is also a key factor here at the infrastructure side. It's about better conditions and multiple electricity related questions. So this is also a key factor. And last but not least, we do believe at Commsignia that certification is the key to have some kind of a good basis for interoperability and trustworthiness. Certifications like the OmniR certification, certifying the industry standard following of the device, and let's say EU Red certification for radio equipment. These are really the building blocks of the trust that we need to have around the infrastructure side. So all in all, having all these components that we have today, like roads, sensors, traffic lights, RSUs, cameras, different detecting algorithms, edge computing and central cloud and central solutions. We do believe that pedestrian protection is an application or a service that needs to run on multiple devices today. So we shouldn't wait for every single component to be connected together. We can have it today. Vehicles could use the sensor data. RSUs could use the sensor data. Smartphones could also be included in this communication even today. Some kind of a central operation and monitoring is needed for incident management. And basically, these infrastructure and this ecosystem can guarantee a much better experience for vulnerable road users. So all in all, I think that was all. Thank you very much for your time, and let's go to the questions part. So let me just wow, thank you very much for all these questions. Let me just choose from those. Okay, just to confirm, vulnerable road user detection with UVB. Yes, UV radars. Yeah, so the question was referring to the fact that if the ultra-wideband radars can, locate the pedestrians, we are going to need some kind of another wireless manner to really communicate with the pedestrians. That is correct. So so that's correct. Thank you very much for the question. The UVB itself is not able to do two-way communication between the infrastructure and the pedestrians, for example. Okay, another question here. Are there pilot deployments of vulnerable road user detections using PSM in the US? Actually, I think there are. So as working with vulnerable road users and solving this problem that I was talking during the presentation is getting more and more focused today. So yes, there are some pilots and trials with regards to that. What data element in the SPAT message is used to indicate VR presence? So the question is referring to the SPAT architecture itself. Actually, I don't want to go into too much details, but map and SPAT messages are just going hand in hand. So we need to have map messages as well to have this kind of a solution ready. Basically, a map message can describe the movements you can take in an intersection. So basically, it's describing whether you can move straight, left, or right in an intersection from the current lane. And basically, the SPAT message is describing the signal phase and status information for each of these connections, lane-to-lane connections in the intersection. And basically, the connection attribute is having a parameter which is describing if a vulnerable road user is detected on that movement path in the intersection. If you just look it up in the J2735, you're going to see that it is inside the SPAT data frame. Okay. So do sensor distinguish between persons, animals, or baby strollers, or bikes, or it's just movement? Yeah, well, this is also a very great question. It's really depending on the sensor itself, and basically the communication mode and the messages you choose when you start solving these problems today. Because having, for example, the SPAT message, for example, you will only have a movement information, if something is going around in the lanes, in the outbound lanes or not. When you talk about, let's say, PSM, pedestrian safety message, you actually have the position information itself, and pedestrian safety message is not really containing any station types, like distinguishing whether that's a pedestrian or a cyclist, because that message is solely referring to pedestrians, as far as I know. But sensors could really just distinguish the different methods that people use to commute. So actually, this information could be included in some other messages as a station information. So you can distinguish maybe what vehicle type you are using or working with. All right, I think I've run out of, many more questions. Thank you very much. I think I cannot handle this question and answer module here, because I seem to have started answering all the questions together and just finished them all at once. So the next question I have here, okay. So there is a question with regards to the availability of V2X communication for all the people. What I can tell is that in the automotive business, it's more and more common to start producing larger and larger batches of cars, including this technology. So what I can tell about this is it's kind of getting a reality today that cars are going to be equipped with this technology. When it comes to pedestrians, cyclists, I do believe that having all those workarounds that I've just told about in this presentation could enable us to start utilizing this technology even today. So I do believe that it could start happening even from tomorrow. I hope this was an answer that could be accepted. Okay. Okay, a very nice question. What is the range of ultra-wideband sensing? This technology is having tens of meters or maybe 100 top most. So basically, this is a short range communication type, but it is also having positive sides of that, because we can choose the frequency very flexibly. We shouldn't really care about jamming and other disturbing factors. So limited range, but good radio parameters come hand in hand. Yes, I did that. So is there a common technology shared between US and EU nations to transmit pedestrian messages? As I was referring to this in the messages part, SPAT message seems to be a very nice fit for this question, because SPAT is a standard message both in the US and in the EU, and this is pretty much having all the components required to describe a pedestrian in an intersection. So that could be a good tool. Okay. Okay, so yeah, the last question I believe I will answer today is that how much power the ultra-wideband communication is needed in the smartphones. This is a low energy communication method, so so you shouldn't really worry about having this installed and activated in a cell phone because it's really designed to not really exhaust the battery and the power performances of the cell phones. So yes. All right. Well, I think that was all as far as I could tell. In case you have any questions, please do not hesitate to drop me an email or drop us an email. I'm sure we're gonna follow up on any questions you have. So thank you very much for your time today, and have a nice day and take care.
Thank you, Matt. We appreciate your presentation and all the questions you answered. Again, this was a presentation from Commsignia. If you have any follow-up, please feel free to reach out to Matt directly. His contact information is on the screen provided. The recording will be presented on the ITS Americas website following this presentation we had today. So we appreciate you all for attending and hope to see you at our next member webinar. Thank you.
Thank you very much.